Hello and welcome to Science. Today we're going to be having a look at orbits. Getting into space is actually pretty easy because it's not very far away. Staying in space is really difficult because gravity is always trying to pull you back down. Because to stay in space, essentially you need to fight gravity. You need to be able to overcome the gravitational attraction of an entire planet, which has a huge amount of mass. So to put something in orbit where it stays up in space and goes around, for example, the Earth, you need to be a bit sneaky. So you balance out gravity with velocity, or in this case, speed, we're going to have a look at. But before we get onto that, we'll just have a look at a few orbits and what an orbit is. So here we have a planet. All the purple here is gravity, and that force is pulling towards the center of the planet. So if you're here, it's being pulled up towards the center of the planet. If you're here, it's pulled in towards the center of the planet. Now, on this planet that is hypothetical, doesn't really exist, we have an absolutely humongous mountain. Now, this mountain is so tall that it extends above the atmosphere. It's really important that that happens so we don't have the friction of the atmosphere to take into account with this bit. On top of this planet, we have, on top of the mountain, we have the ability to fire a gun, let's say. Now, to start off with, we fire it pretty slowly. So what's going to happen? So we're going to fire our gun in the direction of the arrow here. As you can see, that's going away from the mountain. So what path will the bullet take? The bullet will go across away from the mountain, but then the gravity will pull it back down towards the surface. So it follows this curve shape. If we fire it a bit faster, it will follow the trajectory, the path of number 2. So we're firing a bit faster, it spends more time in the atmosphere, it's going further away from the mountain, but then gravity still pulls it back down towards it. But you can see that we've travelled a bit further. Path number 3, we've fired it even faster, and we've got halfway around this planet. So hopefully you can see where this is going. If we fire it fast enough, it will be falling towards the centre of the planet, but missing because the planet's curve, it'll essentially be falling over the horizon, but missing the ground. And that's what's happening at number 4. So we've fired it fast enough that it will just keep going round. The speed has been balanced out by the gravitational pull. So we're constantly being pulled in by the gravity at this point, and the speed is trying to push it away. And this interplay now, we've made an orbit. Now, going back to the idea that there's no atmosphere, there's nothing to slow it down. So the speed remains constant all the way around, and the gravity remains constant. So the two balance each other out. So this is just going to keep going round and round forever because there's nothing to slow it down. Hopefully you're thinking, what happens if you fire it too fast at this point? So I'm going to do it in a different colour because it's getting a bit cramped here. So the red line shows if you fire it too fast or faster than the orbit speed, it still follows a curved path, but the curved path is going away. This is because the forces aren't balanced anymore, and the speed is greater than the force pulling it back in towards it. So we still have a curved path, but it will go further away. If we wanted to put let's say this bullet on this red trajectory at a higher orbit, so further away from the planet, we would have to change its speed and slow it down. At this point here, the dotted line shows where it would go if you didn't change the speed, and it would just keep spiraling out further away. But we're slowing it down at this point. Let's say we've got some kind of a rocket on it. We've slowed it down, and we've got into the right speed for a new orbit. So this orbit here, we'll call this orbit number 5. It will take longer for it to go around this planet than 4 will. The same thing happens with planets. It's not just getting something, the satellite in orbit around the Earth. The same thing happened with planets, because everything is following a path, an either elliptical or circular path around other bodies. So because, as last time we did about gravity, the sun is the most massive object in our solar system, naturally it has the strongest gravity, so things tend to orbit around that. So the planets will orbit around the sun. Now, some of the planets are more massive than the moons that go around them, so the moons of the planets will orbit around the planet. Here's a quick and dirty diagram of some objects in space and showing the different kinds of trajectories they follow. So we've got the sun in the center. Now, do bear in mind that the sun itself orbits the center of the galaxy. So there's a supermassive black hole in the center of the galaxy, which is more massive than the sun, so that will orbit that. And then we've got a planet here orbiting around the sun. So the planet's speed stops it shooting off into space or getting pulled in towards the sun. We've got a moon orbiting the planet. So the moon's speed stops it crashing into the planet if it's too low, or just buzzing off into space if it's too fast. Now, these are roughly circular. They're not entirely circular. They're slightly elongated circles called ellipses. But you can really see that shape for the comet. Now, the comet's speed changes drastically. It's very, very slow, way over here at the top of the ellipsis, and it speeds up the closer it gets to the sun. It puts a big, its fastest point will be when it's closest to the sun here, and then it'll be slowing down as the sun's gravity pulls back on it all the way, but it is in a stable orbit. Next time we're going to have a look at different types of orbit and why we can use them for satellites. Hopefully that gives you a bit of an overview of orbit. The key points to remember that it's a battle between gravity pulling things in and the speed of an object pushing it out. When those two things are balanced, the object will essentially be falling over the horizon, missing the ground. So it's falling but missing the ground, and that's what an orbit is. It's just going round and round and round. Cheers.